morning. Welcome back to module 3 of this course. In this module, we are discussing life cycle assessment, and we have covered 2 lectures previously in this regard. So, in this case, in this specific lecture, I will cover the procedure for life cycle assessment which I have discussed in the previous lecture. I will come up with some examples and some new terms would be there, right. So, I am Dr. Amandeep Singh. Let us quickly recall the procedure for life cycle assessment. Now, LCA procedure included goal and scope definition. Then we had inventory analysis. Then we have here is impact analysis, right, during various stages of manufacturing. Then evaluation and improvement or implementation. Just rewinding it again, this improvement and implementation comes into play when we have the scope is improvement. The scope might be comparison or maybe improvement. So, even during comparison as well, we can if we compare a few products, for example, if we compare one kind of bike with other kind of motorbike, we can select the bike that is eco-efficient. That also, like we have life cycle assessment can also be used in that case as well. So, in that case, this implementation would be selecting that bike, right. So, to understand this procedure in more detail, I will try to explain this with a few examples. First of all, I will take an example of comparison between disposable diapers, disposable versus cloth diapers, right. Okay. So, this example was developed by Franklin Associates, right, in 1992, right. So, there are 2 kinds of diapers available in the market, disposable diaper or we generally use cloth, right. So, while comparing these 2 kind of products, right, of similar segment, the goal and scope here would be goal and scope. Goal here is comparison. So, this is first step in our LCA, right. Goal is comparison and scope is our boundary of like to what extent we need to carry our assessment here. So, here we will start from the raw material, then manufacturing, then end use and disposal. And all the inputs and outputs would be considered here, right. So, next step is inventory analysis. So, typically when these disposable diapers and cloth diapers are compared, there are multiple factors that contribute to determining the preferred diaper. The Franklin Associates here used for the analysis part, they used the process energy. Process energy here is the fuels that are used to manufacture the diaper. Then feedstock energy. Feedstock is the actual material that is present in a diaper, right? And then is the pollutants that are produced. Right. So, this is actually the input here. Besides the inventory, we also have inputs and outputs are here, right. So, regarding some information about diapers, the disposable diapers are generally, the Franklin Associates, they said that use 5 times a day, and a child can in a year use anywhere between 3100 to 3700 cloth diapers, 3100 to 3700 pieces. And the same number in case of disposable diapers comes to be 1800 to 2900, right. So, this is the total usage here. So, when other categories are compared here, disposable versus cloth diaper. So, the cloth diaper, two kinds of diapers were compared. One is that is home laundered, and then there is commercially laundered. Now, they found that 85% of diapers are washed at home, and remaining 50%, 15% are washed commercially. And see look at the way the information that is being procured here, like what is in home, what is commercially laundering, then how much energy is induced while laundering, that will come up the numbers here. Then net use of energy that is embodied in disposable diapers comes about to be embodied energy, right, that was 6900 megajoules, right, out of which about 86% of energy was from feedstock only, and remaining of the 15% was for packaging and process energy. And this feedstock energy, why it is so high, 86%, because the petroleum based products were primarily used. And in cloth diaper, the energy that is embodied in cloth diaper is actually from laundering process, mean this laundering process was contributing, this contributes, right. So, regarding the embodied energies of the diapers that are being compared here, the disposable diapers used 6900 megajoules of energy here, this is 6900, right, and the cloth diapers used a total of 9600 megajoules. And these are cloth diapers that are home laundered, and cloth diapers that are commercially laundered used 8600 megajoules. So, we can see the embodied energies, that is the energy that is induced during manufacturing from the very obtaining of stock to final manufacturing and reaching and the end user. This one was higher for cloth diaper that is home laundered. Actually, this is the main laundering process here that is culprit. right. In this case, cloth laundered, we can say this washing energy is very high. In this case, about 85% of energy is washing, and in this case also about 70% of energy is there in washing. Now, what is this energy? This is actually the washing, the water disposal, the energy is induced in there as well. Now, so we can see the disposable diapers uses about 29% less energy in comparison to cloth home laundered diapers, and the diaper is actually used 160 to 180 times before being thrown out. This cloth diaper, right? Cloth diapers, they are being used in this way. So, another difference between these two kinds of diaper was the amount of water that is used. The cloth diaper that is home laundered used about 34,000 liters of water, and the commercially laundered diaper used 21,000 liters of water, sorry. Okay. So, not only the commercially laundered diapers use a third less water through laundering, they also use 30% less energy. So, also we have here is volume of solid waste. Right. Now, industrial waste here includes the waste that is used to produce diapers, such as raw material, production process, manufacturing, trimmings, ash from electricity, and post consumer waste as well, that refers to substances that are thrown out, like diaper itself, or the soiled diaper, child waste, and packaging, the packets in which diapers come. So, in this case, it was found that solid waste is high for disposable diaper, right. And actually the disposable diaper, the waste, how it is evaluated, how it is considered here, the waste is by volume, not by mass. Actually the waste fills in the landfills, it is the volume that is considered, whatever the mass is. For example, we used to throw a steel or a cotton product, right. It is not the by weight, it is by volume, that how much space would it consume in my landfill, right. So, that was considered here. So, cubic meters per child per year, this much volume for disposable diapers, and for cloth and home laundered diapers it was less, right. Now, this is industrial weight and this is post consumer weight. So, it can be seen there that the solid waste that is produced by the disposable diapers is about 2 times in comparison to the cloth diapers here. Also, there are waterborne waste, right. This was only solid waste. Now, also we have atmospheric waste. What actually we are doing here? We are typically doing the impact analysis, that is the third step, and also we are evaluating, that we will do here. So, regarding the waterborne waste here, cloth diaper produced typically 10.2 kg of waste, and these disposable diapers produced about 9.6 kg. This waste actually come from the raw material production, right, and irrigation of cotton fields from which cloth and the feedstock is produced. And laundering and sewage steps, sewage treatment, right. So, in this case we can see the cloth diaper has higher waste. Okay. Then regarding atmospheric waste, the greatest quantity was observed by the home laundered systems, right. Now, what is the amount here? What is the value? They produced 13.6 kg per child per year. And commercially laundered diapers produced 7.8 kg. Now, disposable diapers produced 6.8 kg. So, why is this value so high? So, home laundered diapers are essentially produced more atmospheric waste because of the washing of diapers at home. Energy is energy intensive, and laundering process indirectly increases the atmospheric emissions that are from electricity generation. This increase is so significant that the home laundered diapers produced more atmospheric waste through laundering than the exhaust that is produced from transporting vehicles, commercial vehicles for the disposable diapers. So, we can see here that in this case, in case of waste, the disposable diapers are winning here. So, certainly when we compare, finally when we evaluate the input and output and we normalize that into single scale, it was recommended that disposable diaper is the winner. Right. So, when determining the best diaper through an energy analysis, a disposable diaper is preferred. However, they produced substantially more solid waste. So, this is life cycle assessment. There is not only one criteria, solid waste is high, or maybe in some cases energy is high. That is not the only criteria. All the factors need to be considered. They need to be summed up, or they need to become brought to a single scale through normalization. Then the final decision is to be made. And in case of diapers, I can also say that it all depends upon the environmental conditions. This is not our mother nature environment, this is the product environment. Environmental conditions means the types of customer, or maybe affordability of the customer, or maybe the demographic area. For example, in drought areas where there is drought, where the water is not much available, so only disposable diaper is the option. And the places where there is a lot of water available, cloth diaper can be one of the option. It all depends upon the place at which we need to we are like going to buy these diapers. And if air pollution problems are there, then resort to disposable diapers. Best diaper ultimately depends upon the community situation as well. Right. So, this is an example of life cycle assessment. So, next I will come to the fifth step here, that is improvement. So, I extended my scope here. My scope earlier was just comparison. So, what was our take from this diaper controversy here? So, impact that is being considered is the energy right? Then water, solid and air waste. Okay. Then when conclusions of LCA study are easily reversed, it is a close call, and we may consider the alternatives as about equally impacting the environment. Most LCAs, however, do lead to definite conclusions. Now regarding improvement here, we need some techniques to reduce laundering here. If I select cloth diaper, like because cloth diaper is not selected here, so I'll work on that. Disposable diaper is selected, so I'll in this case I chose to work on cloth diaper. So techniques to reduce laundering here may be design the fabric in a way that no laundering is required. Design for environment here. How could this be done? Maybe using silver nanocomposites. Okay. Then what else we can do? We can cold wash or dry wash. We can, dry wash means air wash, right? Or maybe sun wash, right? Then if we need to choose washing machine, then washing machine, maybe front loaded washing machine can be chosen because that consumes less energy. So this is one of the example here. So I'll come up with another example here, that is the kind of cup you choose for coffee or tea, right? So I have brought some kinds of cups here. So I have carried with me various kinds of products here. This is a plastic cup, right? This is a disposable cup, and it is made of a very thin plastic here. And second is, this is a paper cup, right? This is made of a paper and a lid is there so that it does not bend so easily. And this is a styrofoam cup. That these three products were all disposable, and this is a regular ceramic cup that we can wash and reuse. So I will not do the factual analysis here, I will not put up all the figures, just qualitative analysis I will take into account here. So when I say I have plastic and paper and styrofoam and a ceramic cup, right? So these four categories, as I told you, for evaluation we will make a table. We make a table here and compare these. So I can choose certain parameters here. Energy conservation, energy conservation means the embodied energy that is induced in manufacturing of this product, right? So embodied energy is essentially the energy that is consumed by all the processes associated, I am repeating, all the processes associated with the production of a product, from the very mining and processing of natural resources to manufacturing to transport and product delivery. It does not include the operation and disposal energy. Operational and disposable energy comes into manufacturing only. So when we think about the life cycle impact, the embodied energy is upstream and front end component here. So, energy conservation, if I say, now plastic cup needs relatively little less energy to make. So, I would say energy conservation is high, and styrofoam is also comparable. It is also here, actually energy conservation is very little energy, I will put it very high. So, I am using the qualitative scale here, very high, like 5 stages are here: high, moderate, low and very low. Okay. So, for paper requires high energy to run mills. So, energy conservation is low here, and for producing china glass needs high energy to run kilns and washing for reuse, etc. So, all here energy conservation is low. So, this energy conservation includes the embodied energy and the energy in manufacturing as well in this case, right. So, next is waste conservation, right. So, in case of this foam plastic, foam styrofoam here, it is high, right. Then in case of china glass, because not disposable, I will say very low, and in case of paper it is again low, and for this plastic it is again high, because these are not biodegradable products. If I say biodegradable, everything is actually decayed. The thing is that plastics do not decay in days or months or weeks, right, or years. It takes millions of years for this to decay. So, anything that is decayed within a specified time, that is within a few months, that can be said as biodegradable, right. So, in this case this waste is high in plastics and in styrofoam. And if I say recyclability, recycle. So, what do you think? Recyclability of plastic is high, and for this ceramic it is maybe moderate. For this paper cup, the recyclability is again moderate, and for styrofoam it is again high, right. So, next is water conservation. Water conservation, it is excellent in case of this plastic, or sorry, for this styrofoam here. So, very little water is required for in manufacturing this. So, it is high, and for paper it is poor, because paper manufacturing is water intensive process, it is low here. And for ceramics it is again no water is required, very low. And for plastic it is moderate, right. So, similarly I can choose other like parameters here, like landfill and air pollutants and impact on ozone layer, or relatively maybe okay, price can be one of the factor here, right. These all price are equivalent, I would say this is low, low, low and high. These three prices are equal, but this is a high price, right. So, regarding air pollution, there is no air pollution here, very low air pollution regarding ceramic cups, and also no air pollution in this styrofoam. It is to be noted, I am talking about air pollution only, not landfill. Air pollution is very low or maybe none, like zero pollution. In these cases, and in plastics also, if we landfill that, it is very low. But papers also they shed some amount of skin of the paper, but I can say, but that is still low, right. So landfill, that it is like, so when I talk about landfill, if I say landfill contribution here, contribution to landfill, that is the, what is the positive impact. So the impact is low in case of plastic and low in case of styrofoam, and this actually turns into the sand, land, like sand itself, ceramic cup, and this actually contribute, the paper actually contribute to methane gas. So it is very high. So next is, I have made the comparison chart here. Now I could give weights here, right. For example, I will give 5 units to this one, 2 units to this one, 1 unit, and maybe 1 unit, 1 unit, 1 unit, and 1 unit, and all these categories are also given some numbers here. It is from 5, 4, 3, 2, 1. So how could I decide finally which product I need to choose here? So I have given certain weights here and certain values here as well. So here for high, the weight is 4, this is 4, this is 4, this is 3, this is the low is 2, 1, 2. The score for this point is 4 into this 4 into 5, that is 20. The score for this point is 4 into 2, that is 8, right. Similarly, I can calculate all these scores here, right, and come up with my final ranking here based on the scores. So when I do this, I will find, it all depends on these values which are given. It all depends. I will find that ceramic cup is the winner here. So ceramic cup, it can be reused, we can wash that again and keep using that. Only thing is that the water conservation here is a little high when we keep on using it. So okay, I will change this water conservation from low to very low to low. So this was very low, I have changed it to low, or maybe I will put it moderate here. So that now is stick into my mind that water is consumed in washing here as well. So I will keep it moderate, right. So it all depends the values which we are putting here, is it in this order 1, 2, 3, 4, 5, or maybe in reverse order as well, right. So ceramic cup is one that is chosen here. So one thing is there, if we consider price as the criteria, that is, if I need to keep this as the criteria, I can even give this as value 10 maybe, right. So this value is 10 here. So when price is criteria, this ceramic cup, for ceramic cup the price is too high. So in this case actually the weight would be 1. If this is low, the weight would be 4 here, it will be 4 here, it will be 4 here, that is this weight category is reversed. So be careful while assigning these things. So in that case, this ceramic cup is crossed. In that case, this styrofoam cup is the winner, right. So this is styrofoam cup, that is winner. So generally, what is the perception here? The styrofoam, it looks like the landfill cost is high. It does not degrade, biodegrade so easily. So this should not be purchased in comparison to this paper cup. But when I do LCA here, I found that this is the winner because of certain other factors that are being considered here. So in this case also, I will tell you one thing, it also includes the lid here, right. So its price of the paper cup is a bit higher than this one, right. For example, if I buy 2 cups, like 3 cups of styrofoam, I can purchase 2 cups of this only. So but the price is not that high that becomes a criteria here. So next is another life cycle assessment criteria, that is EIO-LCA. This is one of the easiest way to assess the life cycle of the product when we consider the whole industries. So this EIO-LCA is an online database, and they have models that have databases regarding the various factors that are in an company. For example, they would provide the number of workers that are in the factory, and the number of the amount of energy that is being consumed, and the carbon emissions that are there, embodied energy that is there. So they maintain the data and provide this one. So this data is, most of this data is open source. So EIO-LCA is actually economic input output life cycle assessment. So economic input and output, the waste that is generated, the carbon footprint of the in the transportation and the packaging waste, all these kinds of things are there. So what does EIO-LCA does? It is actually a method that estimates the material and energy resources that are required, materials and energy resources, and the environmental emissions. Right, of an activities in an economy. Please note, I am not talking about a single factory here, I am talking about a country, right, a specific sector of industry. For example, water intensive industry, for leather industry, or for steel industry, or for automobile manufacturing, or this data would be provided, right, is provided in by this software here. So it was actually developed by an economist who is a Nobel laureate. His name is Vasily Leontief. So he developed this method in 1970s using his work that he did in about 1930s. That was input output work for an economy. Now in the current time, we have a website for EIO-LCA that provides methods and transforms methods for EIO-LCA life cycle assessment and transforms it into user friendly data, right. Right, it transforms into a user friendly online tool to quickly and easily evaluate a commodity or a service as well as its supply chain. Now results from EIO-LCA model and this website are free for commercial use, and it is an online tool. For example, a facility, for a final assemble facility, the impact on maybe metal ores, like impact not on, that impact from the metal ores, right, then making electronic parts, right? Then maybe some miscellaneous things, maybe forming miscellaneous, that is forming windows in an automobile, right, or attaching some other miscellaneous accessories into automobile. All this data is present here. Now, so this is economic input output LCA method. So with this I will stop here in this lecture and would come up with a practice session on this EIO-LCA and other soft tools for life cycle assessment. I will choose one of the open source, or maybe not if open source, maybe the student version of a tool, and we will see how do we do life cycle assessment, how the data is put in, what kind of data is available. So see you in next lecture. Thank you.